I want to talk today about the Pythagorean theorem. Not so much how to use it. You get a lot of information about how to use it. I'll have another video about that. I'm going to talk today about how we know the Pythagorean theorem is true. To see where the Pythagorean theorem comes from, this is one of the proofs that we use, one of the ways we know it's true. I want you to think about this for a minute. What's the blue? I read an article the other day about colors and how different languages, different cultures group colors. To me, that's a kind of blue. I don't know if it's aquamarine or what, but anyway, the thing that looks kind of blue, the rectangle that looks kind of blue, and actually turns out to be a square that's kind of blue. So what's the area, what's the blue area in the two figures? And you notice I made it by putting copies of a right triangle together. One side, one of the legs is 5, one of the legs is 12, one of the legs is 13. So in the left side, I want you to look at the area there and find the bluish area in the right side as well. But before you do that, I'm going to move the triangles in the second figure. So calculate the blue area, bluish area in the first figure and the bluish area in the second figure. And think about what you can conclude from that. Once you've done that, restart the video and you can hear my explanation. Okay, now that you've restarted the video, first of all, most people who tackle this problem say I've got a square, 13 times 13, length times width, or s squared since it's a square. My area equals 13 squared, which equals 169. A lot of people realize the area's got to be the same on the other figure because I haven't changed the size of the triangles. I haven't changed the size of the overall square. I've made a great big square by putting the triangles together. I haven't changed the size of that. But a lot of people will go ahead and, just to verify it, they're going to say the area of this part equals 12 squared. The area of this part equals 5 squared. So the blue area here equals 144 plus 25, which does in fact equal 169. So we can see by doing our calculations that 5 squared plus 12 squared does in fact equals 13 squared. I want you to think about now another situation. Different triangles. I'm not telling you what the triangles are or what the lengths of the triangles are. I'm just saying could be any right triangle. That's our only requirement. This has to be a right triangle. What are the areas now? Well, now the areas are c squared a squared and b squared. And I still know that the two bluish areas are the same. So I know that a squared plus b squared equals c squared. So it does not matter what the shape of the lengths of the sides are, as long as you have a right triangle. A squared plus b squared equals c squared.